Good morning. It's Tuesday morning. We're doing the science notes. And if we pick up where we left off, it's at the very bottom of the fourth page, right down here. Okay? And we were talking about clouds and the different levels, and you have a cloud project with a sheet of paper and cotton balls. Hopefully that's going okay. What we'll do is we'll talk about the notes. Now the shape of the cloud determines what kind of name we give it. And the reason why that is, when you look up at the clouds, how else would you classify them? It's not only the name, but also the height of them. So there's two things: what they look like. Are they chunky, or are they flat? Are they wispy? Or are they low, middle, or high? Okay, so two criteria. So first of all, if it's called strato, if it's sheet-like, flat. Stratus flatus, that's how I always say it. Cirro is curl. Those are usually the really high clouds. Nimbo means it has some raininess with it. It's going to be dark, it's going to be heavy. Cumulo, pile, heap, chunky. Elevation, if it's really high, you're going to find the cirrus clouds, very delicate and wispy and curled. Those would be completely ice crystals floating way up there. In the middle, so you're coming down, that middle part, you hear the word alto in there quite a bit. Alto cumulus would be middle, chunky. You'll see small patches, bands across the sky. And then the very low clouds are usually going to be stratus. That's what I see today. Very thick stratus, flat clouds, smooth, even sheets, thick gray blanket, brings drizzle, rain, or snow, which is kind of what today is. The vertical clouds, that would be on the last slide, that big tall one that we had. That's called the cumulonimbus cloud. Cumulo because it's chunky, nimbus because it's got rain in it, and it's more than one height. It stretches from the low to the middle to the high. And that's because you have that warm air rushing up, the cold air rushing down to replace it, and you get all that action going to form thunderstorms. Okay? So make sure you catch up on those notes, fill those in. We'll move on to the next one. These are different examples of the clouds. Cirrus, that's the wispy. Cirrocumulus, so they're high, but there's a little bit of chunk to them. Then you have middle clouds, so alto, cumulus to the right, and then just lower cumulus ones on the left there, both chunky. Stratus flatus, the one on the left kind of looks like what it is today, so low, flat clouds. Stratocumulus, so it's got some sheets to it, but also some chunkiness to it. I hope you get sort of the idea of what you're looking at there. Nimbostratus means that one's going to rain. Cumulonimbus on the left, that's that storm cloud that's going to stretch from the lowest to the highest. The warm air rushing down, the cold air, the warm air rushing up and the cold air rushing down. On the right there are some other peculiar clouds, and that's a real peculiar one. And remind me, I got to tell you a story about that exact picture when you guys come back. But that's a really weird looking one. You don't have to know the name of that cloud, but I think it's a really fascinating one. Then if we move on, we're going to lesson 3. How is technology used to collect weather data? The video I have on the bottom right link is to a Studio C weather forecast. If you want to Google it, go ahead. But otherwise, we're going to move on. And if you look at it, the history of forecasting goes back a long ways. The Babylonians are the first that we hear about reporting. And what they did is they didn't have instruments. What they did is they collected data. And they said, you know, it's got this kind of cloud today, and then it rained, or it had this type of weather condition, and then it did this. And then they get to go look back and say, huh, Okay, we see a pattern there. So that would be the first style of forecasting. Then you started having people invent things. Romans, the wind vane, which is still used. Little side note, churches often put the rooster on top to remind us of not turning our backs on God, or not forsaking Him, because the rooster crowed 3 times after Peter had disowned Jesus 3 times. So it's always kind of that reminder, don't disown Jesus. Anyway, that's the wind vane. Later on, the Greeks coined the term meteora, which means things in the air, so we get the word meteorology, study of things in the air. Again, it's based on observations. Also, they started talking about little old proverbs, or some people might call them wives' tales, where, you know, red sky at night, sailor's delight. Red sky in morning, sailor take warning, or those kinds of things. And they can sometimes be accurate, but not real accurate. If we move on to the 15 and 1600s, this is just brief history here. You had a guy named Galileo Galilei who invented the thermometer, Evangelista Torricelli, the barometer, and both of those worked on the principle of expansion and contraction. When you warm something up, those molecules move faster and further apart so that they will spread. If they get slower, those molecules move slower and come together, and it shrinks. And what you see over here is a tub of mercury. Here's one too, an old thermometer. They don't use mercury much anymore because it's not a real safe thing to always handle. But mercury has a really interesting quality in that it won't freeze unless it gets like negative 200 or whatever degrees. And it won't evaporate. And what you have is that liquid, it just stays as a liquid. And it's really heavy, really dense. You can even float, you know, a bolt on top of it. If you want to Google YouTube with your folks and watch cool things with mercury, that's what all these links are for. But what would happen is if the air would have a higher pressure, if we're talking about a barometer right now, it will push down on the mercury there and then force the mercury up this glass tube. So you could determine, is it a high air pressure outside pushing down and pushing that up? Or is it a low pressure and then this drops? When we talk about a thermometer, also if the mercury heats up, it moves faster and further apart and it starts going up the tube. And then if it cools, it goes down the tube. Now we've replaced mercury with other liquids and just very little bit of, it's kind of like the stuff that you'd use in your car engine to keep it from you know, overheating. You stick this coolant in the radiator, yet on a really cold day it won't freeze. So it's called antifreeze. And that kind of stuff gets used. This is the telegraph, and it was invented by a guy named Morse, that's his last name. And the reason why that plays a role here is if we found out that out in Blaine they got a storm and it's coming our way to Linden, someone in Blaine could make a quick little message to us, and an instant message, the old time Instagram, I guess, and send it right across the wires to us really fast, saying, hey, prepare, this is coming. So that really affected how we forecasted weather. Then the United States decided to come up with its own branch of the government, U.S. Weather Bureau, in 1890 because they felt it was so important. I'm going to stop right there and continue in a little bit.